Hey guys, here's a little video for you about the six trig functions. And you're going to remember some of this from geometry. So the right triangle trigonometry, there are six possible ratios or functions. Now remember, a ratio is just a comparison of two numbers. We're going to be comparing the side lengths of the triangle by division. In other words, a fraction. So the Greek letter theta will be used to represent the reference angle, and that's just kind of like using a variable x for some unknown angle. Maybe the angle's 30 degrees or 45 degrees, but we don't know. So we're just calling it theta, kind of like we would use x for some unknown number in algebra. So remember in your right triangle geometry that the side that is opposite your 90-degree angle is always called the hypotenuse. And no matter what angle you're referencing, that will always be true. The other two sides will change depending upon what your reference angle is. So notice this bottom right corner is our reference angle. And so if you go across from or opposite that angle in the triangle is this side right here. So the length of this side will be your opposite. And then the other side of your triangle that's not the hypotenuse, that's not opposite, is called the adjacent side because it is right next to your reference angle. Okay, so the adjacent side will always form one side of your reference angle. Now, the thing to note is if I were to change my reference angle, let's say that my reference angle or the angle that I'm interested in is this one here in the top of the triangle. Well, if that were the case, then my adjacent and opposite would change, because if this is my reference angle, then the opposite side is this one, and then the adjacent side would be this one. So if I change my reference angle, then opposite and adjacent will change. But the one thing that does not change is the hypotenuse of the triangle. It will always be opposite your 90-degree angle. Here's a table, and you might want to snap a picture of this or write it down somewhere, because this is the definition of all six trig functions. You're probably familiar with the first three, sine, cosine, and tangent, because you learn about those in geometry. You might remember SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. But we're adding these six, secant, cosecant, and cotangent, and really they're just the reciprocals. Notice that if you were to flip opposite over hypotenuse upside down, then you would end up with hypotenuse over opposite, which is cosecant. If you flip adjacent over hypotenuse upside down, you end up with secant. And if you flip opposite over adjacent upside down, you end up with cotangent. So these last three are just the reciprocal of the first three. So sine is the reciprocal of cosecant, cosine is the reciprocal of secant, and tangent is the reciprocal of cotangent. We use abbreviations like we often do in math, and generally it's the first three letters of the word, except for cosecant, because it has the same first three letters as cosine. And so we abbreviate it CSC. So that's the only one you kind of have to think about. So again, hopefully you've written this down or you've taken a little snapshot of it so you can reference that later if you need it, because we're going to do an example. So here we have a triangle and we want to find the six trig ratios. And I want you to notice that in the parentheses we have the letter B. That means that angle B is the reference angle that we're asking about in this particular problem. So if this is angle B, then 4 would be your opposite side. 7 is your adjacent side. But we do not know this hypotenuse. But that's okay because we know the Pythagorean Theorem. And if you have a right triangle and you're missing a side length, just use the Pythagorean Theorem to find that missing side. So I have that math here. So a squared plus b squared equals c squared. So c can be found by taking the square root of a squared plus b squared. Well, a and b are 4 and 7. The two sides that are not the hypotenuse are a and b. And so we just substitute those in. So 4 squared is 16, 7 squared is 49. And so this side is simply the square root of 65. So now I know all three sides and I can find these ratios. Now remember, you can scroll back up here if you need to, or look at your reference sheet. We know that sine is opposite over hypotenuse. Well, the opposite side is 4, and the hypotenuse is the square root of 65. So sine is just 4 divided by the square root of 65. Now, if you want to pause this video and see if you can figure out the ratios of the other 5 trig functions now that we've done this first one. Okay, so hopefully you paused the video and you thought through these problems. Let's see how you did. Now, cosine is going to be adjacent over hypotenuse. So this over this. So 7 over the square root of 65. Tangent is the opposite side over the adjacent side. So that should be 4 over 7. Now, these next 3 are the reciprocals, and a lot of times you'll see them lined up like this with the first 3, and then the next 3 in the order of their reciprocal. So cosecant is the reciprocal of sine. So a lot of times you'll see those right next to each other and so on. So cosecant is hypotenuse over opposite, simply the reciprocal of sine, so the square root of 65 over 4. Secant is hypotenuse over adjacent, so that's the reciprocal of cosine. And then cotangent is the reciprocal of tangent. So hopefully you were able to find all of those ratios. Now I do want to make note of one thing. We have a couple of ratios here that are not considered rationalized. You will notice that sine and cosine both have a square root in the denominator of the fraction. And that is considered not rationalized. So a lot of times you'll see these converted by simply multiplying the numerator and denominator by the square root of 65. And I'll go over that in another video. Here is an example that many of you were struggling with. It says, write an expression using the 6 trigonometric ratios that equals 10. And some of you, it asked you to write an expression using the 6 trigonometric ratios that equals 1 or that equals 3 or some number. But I just selected 10 so we could take a look at this. So the first thing that I want you to remember is that each trig ratio has a reciprocal. And we know that when we multiply reciprocals, the answer will always be 1. And so that's the trick here, to note that if you multiply sine times its reciprocal cosecant, that equals 1. And cosine times secant equals 1. And tangent times cotangent equals 1. Now, one of the ways that you can remember this is notice that each of these has one of the 3 original trig functions, sine, cosine, and tangent. And then if it doesn't have the word co with it, then the other function is the co. So sine goes with cosecant, cosine goes with secant, and tangent goes with cotangent. So One of them is a co and the other one is not. The other thing I want to make note of here is I put a multiplication symbol here in between these, but we know in algebra that you don't have to put the multiplication sign. All right, we could just write it this way: sine x cosecant x equals 1, and so forth. So now that we've established that, we can go back to the question. Remember what the question asked. It said, write an expression using the 6 trigonometric ratios that equals 10. So now that I know what these 6 equal, then I can simply write an expression such as 3 times sine x cosine x. Remember, sine x cosine x equals 1, so 3 times 1, plus 3 times cosine x secant x, well, that equals 1, so 3 times 1, plus 3 times tangent x times cotangent x, so tangent times cotangent is 1. So this says 3 times 1 plus 3 times 1 plus 3 times 1 plus 1 equals 10. And we could actually write this a little different if you wanted. So we could write sine x cosine x minus cosine x secant x plus 10 times tangent x cotangent x. So this would be 1 minus 1 plus 10 times 1 equals 10. Or how about this one? 10 times sine x cosine x, that'd be 10 times 1, plus 10 times 1, plus 10 times 1. So all of this in the outside parentheses is 10 times 1 plus 10 times 1 plus 10 times 1, which is 30, divided by 3 equals 10. So you can see that the possibilities are endless. So there are a lot of right answers that you could have done here. All right, let's look at another example that many of you were struggling with. Get rid of this. These boxes are hanging on for some reason. Okay, so another question that many of you were struggling with said something like this. Given that theta is between 0 degrees and 90 degrees, and the tangent of theta is 7 over 8, find the other 5 trig ratios. Okay, so I'm going to just remove this. Okay. Okay, so remember that the tangent of theta is simply opposite over adjacent. So the opposite side is 7 and the adjacent side is 8. I think I just removed my 7. So let me put that back in here. So let me insert text box. And I get a lot. Ooh, let's just undo that. So I'm going to insert a text box, but I want to draw the text box. Okay, and I'm going to put a 7 here. And I do not want to outline this, so there we go. Okay. All right, sorry about that. So the opposite side is 7, and the adjacent side is 8. So that's given from this tangent theta is 7 over 8. So what we need to do is just draw a triangle, and then we are going to, it says, label the triangle with these numbers I've done. And now we're going to use the Pythagorean Theorem to find the missing side. So I'm not going to go through the Pythagorean Theorem, but the square root of 7 squared plus 8 squared is the square root of 113. So your hypotenuse is 113. So this is the triangle that you can use to find any of the other trig ratios. So now we're ready. So here are the other. Now notice I already filled in tangent. That was the given one. So for sine is opposite over hypotenuse. So it's going to be 7 over the square root of 113. Now that is not rationalized, but we can talk about that later. Why don't you pause this video and see if you can find the rest of the trig ratios based on this triangle. All right, let's see how you did. Now, once you find sine, cosecant is just the reciprocal of that, so that's nice. Cosine is going to be adjacent over hypotenuse, so that's going to be 8 over the square root of 113. Secant will just be the reciprocal of that. We already know tangent, so cotangent's easy enough. It's just the reciprocal of tangent. How'd you do? All right, so please leave me some feedback about the quality of this video. And if it helped you, I'd love to hear that, or whatever your suggestions are. Love you guys, miss you so much, and good luck.